In this video, I'm going to be talking about finding the slope between 2 points. Now remember that the slope, in very general terms, is going to be the rate of change of one quantity with respect to another quantity. But more specifically for our case in this video, we have 2 points, and we know that between these 2 points is going to be exactly one line. So we're really finding the slope of that line, or the steepness of that line. So is the line almost vertical, like it's really steep, or is it pretty horizontal, it's a pretty shallow line? So let's go ahead and see. Our first example, we have the point 2, 3, and 7, 5. Okay, and our slope formula, and m represents slope, is going to be y2 minus y1, or we could say the change in y, all divided by x2 minus x1, or we could say the change in x. So another way to look at this is how much is y changing divided by how much is x changing. Well, our y2 and y1, x2 and x1 are going to be some variables that we need values for. So we can look at our points, and we know that each point has an x-coordinate and a y-coordinate. And we could call this first point, point 1, so we'll put a little 1 by each of those coordinates. And then our second point could be point 2, so we'll put a little 2 for the subscript of each of those coordinates. So now it seems like we have all 4 of our variables. We have values for them. So we're going to say the slope, or m, equals y2 minus y1. So y2 is 5, minus y1 is 3. And that's going to be divided by x2 minus x1. So x2 is 7, minus x1 is 2. And it looks like 5 minus 3 is 2, over 7 minus 2 is 5. So in this case, our slope is going to be 2/5. In our next example, we have 2 more points, -8, -1, and 7, 4. Okay, so still, we're going to use our formula, y2 minus y1 over x2 minus x1. And in our case, we have an x and a y, and another x and a y, and this could be our first point, and this could be our second point. So we have the value then for each one of our variables here. So y2 minus y1 will be y2 minus, and you got to be really careful when you have negatives over here that you're subtracting, because y1 is going to be a -1, so it's going to be y2 minus y1, which is negative in our case, so we're going to be minus a negative number. So x2 is 7 minus x1, which is another negative number, like that. So remember, when you're subtracting a negative, you can go swoosh, swoosh, and make them plus problems, or addition problems, plus signs. So 4 plus 1 over 7 plus 8 will be 5 over 15, which we can actually reduce, because we're going to divide both the top and bottom by 5, and we'll get 1/3 for our slope. In our third example, we have the points 6, 2 and -3, 2. So again, we're going to write our equation y2 minus y1 over x2 minus x1. And again, we have x and a y and an x and a y. We can call this our first point. And this other one can be our second point. Okay, so y2 minus y1 is 2 minus 2, which will actually end up being 0. And our bottom, x2 minus x1, will be -3 minus 6, which will be -9. But we have 0 on the top here, so over some quantity that's not 0, so we know it's just going to be 0. So my slope is just going to be 0 in this case. And remember, the slope, that's 0, is going to be a horizontal line. We'll talk more about that in a later video. In our fourth example, we have the points here, 3, -4, and then 3, 1. So to find our slope, just like we've been doing over and over and over again, we have our formula, y2 minus y1, all being divided by x2 minus x1. So we have our x1 and y1, and we have our x2 and y2. So we'll just go ahead and plug our values in. y2 minus y1 should be 1 minus a -4. And x2 minus x1 should be 3 minus 3, which, interesting, on the bottom looks like we're going to get 0. On the top, when we go swoosh swoosh, we get 1 plus 4 is 5. Well, we cannot have division by 0, so we're going to say in this case that it's going to be undefined. So our slope then is undefined. Well, what kind of a line has an undefined slope? Well, that's going to be a vertical line. So all vertical lines have an undefined slope. And again, we'll talk about that much more in a later video. It looks like our next example is going to contain fractions. So our first point is negative 1/7, 5/7, and then 3/14 and 3/7 will be our points. So we can call this one x1, y1 with x2, y2. And I've already got my formula written here. The slope is the change in y over the change in x. So y2 minus y1. So this y2 is going to be 3/7 minus y1, which is going to be 5/7. Okay, on the bottom we'll have x2 minus x1. So 3/14 minus a negative 1/7. Okay, so as we move over here, we have common denominators in the top already, both 7ths, so it's just 3 minus 5 will be negative 2/7. But on the bottom we'll have to get common denominators, so it looks like we're minusing a negative, so swoosh swoosh, we're going to make an addition problem out of it. And then our common denominator looks like it should be 14, so 3 over 14 plus something else over 14, so we'll have to times the top and the bottom by 2, so 1 times 2 is 2. So now we have common denominators. It looks like 3 plus 2 should be 5 over 14. Alright, we kind of have a complex fraction here, a fraction within a fraction. But remember, fractions just mean division, so I'm taking this fraction in the numerator divided by this fraction in the denominator. So really when you're dividing fractions, you copy dot flip, or you can say you multiply by the reciprocal. So it should be negative 2/7 times the reciprocal, 14 over 5. Well, my 7 and my 14 I can reduce by dividing out a 7. So I get 1 on the bottom and 2 on the top. So when I finish that up, negative 2 times 2 is negative 4, and 1 times 5 is 5. So it looks like the slope for that problem is negative 4/5. In our previous example, we had fractions for our coordinates, and this time we're going to have decimals for our coordinates. So it's going to work just the same. We'll have our slope formula, y2 minus y1 all over x2 minus x1. And again, we can do our coordinates. We can say this is guys are x and our y, x and our y. We could call this one the first point and this one the second point. So y2 minus y1 should be 0.6 minus a negative 0.9. And our bottom, x2 minus x1, should be 2.2 minus 2.7. So here, like we've been doing, when you subtract a negative, you turn it into an addition problem. So 0.6 plus 0.9 should be 1.5. And then 2.2 minus 2.7 will be a negative 0.5. So we have a fraction, but our fraction includes decimals in the numerator and denominator. So if I multiply the top and bottom by 10, it looks like my decimal point will move here and move here. So I have 15 divided by a negative 5. Well, that's a lot nicer. That's going to be a 3 over a negative 1. We don't want the negative to be on bottom, so we're going to bring him out front there, which would just leave a 1 in the denominator. But we don't just want the 1 in the denominator, so we'll leave him alone. So it should be negative 3 for our slope. So anytime it's over 1 like that, we're just going to eliminate the over 1 and just leave it alone like that. So we just have our numerator. So our slope in this case is negative 3. In the last problem in this video, I want to discuss something that sometimes students struggle with. So does it matter if we call this one point 1 and this one point 2? Or does it matter if we call this one point 2 and this one point 1? So the idea is, does it matter which way we subtract from? So does it matter 2 minus 7 and 8 minus a negative 2? Or could we just as easily go 7 minus 2 and negative 2 minus 8? Well, either one of those will be fine as long as you go in the same direction every time. So what that means is students, they sometimes leave out writing the equation for the slope, and they leave out labeling all these points, and they just want to say, well, I'm going to subtract these two things and these two things, make a fraction, and here we go. But you have to be careful when you do that. So the question was, does it matter if this is point 1 and this is point 2? Well, let's call this one x2 and y2 this time, even though all the rest of the videos so far, the rest of the problems we've been doing the other way around. So y2 minus y1. So 7 minus 2 over x2 minus x1, negative 2 minus 8. Well, 7 minus 2 is 5, and negative 2 minus 8 is negative 10. So I have that single negative sign, so he'll still exist in my final answer. So I'm going to bring him up top, and then I'm going to reduce, divide a 5 out of each one of those. So I get 1/2 for my slope. Okay? Well, what if I'd gone the other way? What if I'd said, instead of 7 minus 2, if I'd said 2 minus 7? So let's just go backwards for both of these. So 2 minus 7, so this one minus this one, and then 8 minus a negative 2. Well, the minus and negative on bottom, swoosh, swoosh, so it'll be a positive here, so 8 plus 2 when we add those things. And then 2 minus 7 will be a negative 5. And then when we reduce that, we get a negative 1/2, which is exactly what we had before. But if you'll notice something, on the previous fraction we had the numerator positive and the denominator negative. And in the second one we had the numerator negative and the denominator positive. But it still made them each negative. Well, the problem some students have, and this is the mistake that they make, they want to say 7 minus 2, like that for the slope, and then they go 8 minus a negative 2, and they get 5 over 10, which is positive 1/2, which is not the correct answer. So whichever way that you're subtracting from, whether it's left minus the right or right minus the left, just ensure that your numerator and your denominator are going the same direction. So either from this point minusing this point, or this point minusing this point.